Determine if the scenario involves mutually exclusive events, then find the probability. There are 11 shirts in your closet, 5 are blue, 3 are green, and 3 are red. You randomly select one to wear, find the probability that the shirt is blue or green. So I'm going to begin by outlining the addition rule. The probability of A or B is going to equal the probability of A plus the probability of B minus the probability of A and B. Now, if my two events have something in common, then they're going to be inclusive. However, if they have no such thing in common, then I'm going to say they're exclusive, and this is just going to be equal to 0. So here, I'm going to use this formula to address the problem of getting a shirt that is blue or green. That's going to equal the probability of getting a blue shirt plus the probability of getting a green shirt, and then I'm going to subtract the probability of getting a shirt that's blue and green. Now the probability of blue, well, I have 5 out of 11. So I can put 5 over 11 plus the probability of green. And the probability of green is going to be 3 since I have 3 green shirts. And I'm going to divide 11 since that's my sample space. Those are my number of possibilities. Now notice that this problem doesn't give me any information about shirts that are both blue and green. So this is going to go to 0, and I can say that this is going to be an exclusive event. Now all that's left to do is to add these two fractions, 5 plus 3, that's going to be 8. And we keep the denominator 11, so the probability of blue or green is 8 over 11. Let's look at one more example. Here I have a box that contains 5 red playing cards numbered 1 through 5. The box also contains 5 black playing cards numbered 1 through 5. You randomly pick a card, find the probability that the card is red or has a number less than 4. So I'm going to begin by grabbing the addition rule, and then I'm going to use this as an outline to address this specific problem. The probability of red or getting a card that's less than 4. That's going to equal the probability of red plus the probability of something less than 4 minus the probability of both grabbing a red card that's less than 4. So in this case, the probability of red, I have 5 red playing cards, and then I have a total of 10 cards because I also have 5 black playing cards. So the 5 black plus the 5 red gives me a total outcome of 10. 10 is the sample space, all of my possibilities. So I'm going to add this to the probability of getting something or getting a card that's less than 4. So in this case, I'm going to have 3 red playing cards that are less than 4, and I'm going to have 3 black playing cards that are less than 4. 3 plus 3, that's going to give me 6 out of 10. Now I'm going to subtract the probability of getting a red card that's less than 4, and that should be 3 out of 10 since I only have 3 red cards that are less than 4. Since I do have an intersection, these are inclusive events. Now let's go ahead and calculate the probability. 5 plus 6, that's going to be 11 over 10. And if I subtract 3 over 10, I'm going to be left with 8 over 10. So the probability of red or getting a card less than 4 is going to be 8 over 10.